Okay, so we're going to look at section 1.1, graphing relationships. Graphs based off of word problems, okay? So we're all going to learn to love word problems by the end of this class period. So on example 1, it says the air temperature was constant for several hours at the beginning of the day. For 7 hours. It's the same temperature for most of the day before dropping sharply at sundown. So we're going to sketch a graph to represent that, okay? And so I, for this part, wrote down our words that were important, okay? So this our air temperature was constant, okay? So constant's one of our key words. Then it rose steadily, so rose steadily. Stayed the same, and then dropped sharply, okay? Those are our key words. That is what is telling us what our air temperature is doing. So we're going to sketch a graph to represent that. So I'm going to start with constant, okay? Constant just means that we have a flat line, okay? So the air temperature was constant for a while. Then it says that it rose steadily, okay? So we're going to slowly increase on our graph, okay? An increasing line where it rises. Then it said that it stayed the same, which again is constant. So we're going to have some type of constant air temperature for a while. Then the last thing that it says is that it dropped. So we're going to have a graph that goes down, but it's going to go down very steep. Okay? Kind of drop sharply. Okay, so we're going to look at our word problems and pick sketch graphs to represent them. Alright, so if I look at check it out 1A, if I look at that word problem, it says the air temperature increased steadily for several hours and then remained constant. Okay? Increased steadily. And then it says that it was constant. So there's my keywords for the first sentence. Second sentence says at the end of the day, the temperature increased slightly again before dropping. So it increased slightly. And then it said it dropped sharply. Okay, and so if I take that information, I'm going to air temperature. So we'll start with increase steadily. If it's increasing, then our line is going up. So we're going to have a line going up. Okay, then if it's constant, what's our line going to look like? It's going to be straight. So we're going to have a constant for a while. Then we go back to increasing slightly. So it is going to increase, but only a little bit. And then the last thing that it says it does is drop sharply. So what direction is my line going then? Down. So it's going to be going down, and it's going to go down really, really fast. Okay, so my graph will look something like that for my air temperature. Okay, so we just looked at types of graphs. Also, we're going to look today at discrete graphs. What are you doing? I know. I was going to fix it because it had a spelling error, but... Okay, so continuous graphs are graphs that are connected or curved. So we just looked at that where we had lines that were all connected, right? Okay, so other type of graph that we're going to look at today is a discrete graph, which is just distinct points. Okay, so continuous graph would look something like that. A discrete graph would look something like this, where it's just a bunch of points. Okay, no lines. Okay, so let's keep looking at graphing from word problems. So if I look at 2A, it says Simon is selling candles to raise money for the school dance. For each candle he sells, the school will get $2.50. He has 10 candles that he can sell. So we're going to graph that, okay? So each one of these lines is going to represent $2.50. And each one of these lines represents one candle sold. Does that make sense? So if he sells one candle, how much money does he make? $2.50. Okay, what about two candles? $5. Okay, and three candles? $7.50. Okay, $4 would be $10. And then we just keep going up by $2.50 every time, right? Until we sold all 10 candles. Those are the evens. Something like this. Okay, so then what type of graph is that? Perfect. Because it's a bunch of distinct points, it's a discrete graph. Okay, so think about like continuous being connected lines, C and C, and discrete being distinct points, D and D. Okay, the words sort of go together. Heart rate. Okay, so we're looking at Angelique's heart rate as she's walking on a treadmill. Okay, so it says while she's walking, her heart remains the same. So, what type of line are we going to have? A constant line, okay? And it's going to be somewhere up here because if it was at 0, she'd be dead. Okay, so we've got a constant line. Then it says, as she increases her pace, her heart rate rises at a steady rate. So my line is going to be rising, going up. Then it says, when she begins to run, her heart rate increases more rapidly, and then it remains high while she runs. So it's rapidly. So it's still going up, but it's going up really sharply, right? What type of line are we going to have? So back down to just being constant. And then finally it says as she decreases her pace, her heart rate slows down and returns to the normal rate. Okay, so if we're slowing down, what's our line really doing? It's going to be dropping, right? And it's dropping steadily until we get back down to the normal rate. Okay, and what type of graph is this? Continuous. And remember, your vocab's highlighted in yellow in your book, so if you forget, you can look at the yellow words. Alright, and the last thing we're going to do is we're going to come up with a situation represented by this graph. Okay, so we're given this graph where we have water level over time. Okay? And so we need to come up with a thing that has a water level that would represent that. Okay, so what has water? Or would have a water level? A pool. Okay? That's what my fifth hour uses too. Alright, so we're going to be looking at a pool. Okay? So, red part of my line. What's my pool doing? It's increasing steadily. So, my water is increasing steadily. If I go to the line, what's my water level doing? Okay, it stays as a constant, so water stays the same. And then lastly, for my green line, what are we doing? It's decreasing, right? Okay, so what would cause a pool to decrease? Okay, so water splashing out, but that'd be like a really fast decrease, right? What causes something to decrease steadily? Emptying it. Perfect. So we're like draining our pool. So then our pool gets drained. So we're draining our pool. Okay, so up here we could have said that we were filling the pool. And then just swimming in it. And then we drain. Okay? So that's what you guys will be doing today. Your time is going to be 167.